consider this. Okay, so we have a tightrope walker. Okay, you notice here he's handling it quite easy. Notice what he's holding. So when you think of him, you should think of his moment of inertia along with the moment of inertia of the rod he's holding or the pole he's holding. Their overall moment of inertia relative to the position of the feet. So by having a high moment of inertia, he's capable of being more stable. Now look at this one where he's not carrying a pole. You see that he's not as stable. It's more difficult to keep the state of motion constant. Now his rotational inertia is less, but he's trying to increase it anyway by having his hands apart, his arms apart. Okay. So same idea. So the pole in that case was used to try to increase the rotational inertia. Okay, see here, the ropes are not as tight and they are not really walking over a great height, so it's a little easier to do. But you see in both cases, or in all cases, they try to increase the rotational inertia by having their hands lifted apart. And remember, we are thinking about rotational inertia relative to where their feet are, because if they are going to fall, they are going to rotate about that position. That's the pivot point. The pole adds an increased rotational inertia just because of the existence of the pole to begin with, but then the fact that it extends so far away from the axis increases the rotational inertia quite a bit.